Hello everyone, today let's take a look at this very interesting attack called privilege escalation. So this is the setting of our experiment. We have the server which is managed by the administrator that runs certain service, and we have a client which is managed by the attacker. The attacker has an account called Tom that using that account the attacker can remotely connect to the server. For example, in this client machine, when the attacker issued the command SSH Tom and followed by the IP of the server, he should be able to connect to the server. However, this account Tom has very limited permission that he cannot visit very important critical security files, for example, password file on the server. Let's say that the attacker want to check the password file by using a cat. He got permission denied. So in this lab, we are trying to show you that the attacker is able to modify the configuration files on the server by leveraging the vulnerability of the server machine and then to get the root permission. Here we already implant the payloads by leveraging the vulnerability of the server. At this time, the client only needs to turn on the netcat account and start to listen at certain port 443. While he is listening, he is waiting for the administrator on the server to restart certain service. Remember that in this lab, the configuration of that service have vulnerability, and the attacker is leveraging that vulnerability to complete the attack. So what the administrator did is that, let's say at one point the administrator wants to restart the networking service of this machine by issue this command, and then from the client side, you will see that he will automatically receive the root permission here. As you can see, he got the root shell, and with that he can basically look at any file he wants and also to modify any critical files as he wish. For example, he can issue the command to actually check the etc shadow, and then now you can see that he can see all the password of different users. Let's say this is user for user student, and this is the password for that user. And even though this password is in a hash format, the attacker basically can try to do the password cracking to figure out the password of that account, of the account student. Then he can basically get the same permission as the administration on the server. Right. So to start this lab, you probably need to know some prerequisite knowledge. Firstly, you need to know what is a secure shell or SSH. SSH is a network protocol for operating network service securely over an unsecured network. It is usually used for the remote logging and command line execution, as we have demoed in here. In our demo, we show that the attacker basically can remote SSH to the server with the account Tom, and then so once he log in, he basically already get access to the server, and he can perform any command he want. This is only one ways to remote connect to the server. The user can also log in the server with the private key if he want to reset that. That's going to be use option -I. For all details about SSH, you can find it in this link and also in this YouTube video. And another thing that you need to understand is about etc shadow. For some of you who are not very familiar with that, this etc shadow stores the password of all the users on the Linux machine. And there are another file called etc passwd. The name sounds like storing the password, but in fact it only stores the user. actually all the users are able to read this file so that he can know the users of all the users on the Linux machine, but not all users be able to see the password of the users. With this password file, with this shadow file, only root have the permission to read and write, and only the users in the group shadow are able to read it, and other users don't have any access of it. So if you take a look at this, so let's say that now we are having the remote connect to the server with the username Tom. If we wanna check the etc password, it's allowed it, right? So you can see that this basically is the student, and this basically shows the certain configuration of the student account. But again, if you try to list the shadow file, you won't be able to visit that. So this is about the shadow file. So normally the goal of the attacker is trying to get the shadow file. Once he gets the shadow file, he is able to reverse to crack the password. This is basically a typical example of the shadow file. As you can see that shadow file consists of multiple lines. Each line will list the password in a hashed format of different users. In this example, as you can see that this user basically is using number one algorithm to hash his password, and different number represent different algorithms. If the number is 6, basically is hashed with hash shell 512, which is the safest hash algorithm that can be used so far. And also the second item after the number would be the sort. The idea would be the hash of the password is generated by combining the real password and the randomly generated sort, so that even though different users are using the same password, the generated hash will be different. And there will be other items after that listing different things about the user. For example, the last password change, the minimum number of days required to change the password, and so on. So with that, to prerequisite knowledge, let's talk about the attack plan. So we have already know that we have a server and we have a client, and in the server, basically, in the server we have the etc shadow file that have the permission 640, meaning that the normal client won't be able to visit that file at all. However, there's a service called the network service. It's actually controlled by the configuration file called etc init.d networking. With that service, that service is used to start the networking service. But in order to do that, the administrator of the server needs to use the sudo command to start the service. However, this sudo command, once the sudo command is executed, this script is executed. In the root permission. However, the administrator of the server made some mistake that they misconfigured the permission of this file as 777. As a result, that means anybody can modify this file. That actually can generate the loophole of the system. The client, let's say the attacker, is controlling this client so that he can visit the server with account Tom. As a result, the Tom can modify this file. right? Because this file has a permission of 777, anybody can modify this. When Tom can modify this file, Tom can basically inject some payloads. What the Tom can do is that he can inject something called a reverse shell. So reverse shell basically is a shell connection technique that allows the victim, in this case the server, to connect to the client directly. As we can see that the client basically only needs to open a listener on his machine, and the server will be able to once this service has started, then the reverse shell will be able to have the server to remote connect back to the client. That triggers the attack. So this is something about the privilege escalation, and you can follow the instruction to work on the lab. And I hope that you enjoy the lab, and let me know what you think. Thank you.